brings me down. You're the cure, my love. In a bad rainy day, you take all the worries away. Love you every minute, every second. Love you everywhere, and you're the more my always and forever. In a bad rainy day, you 'cause baby you're the one I don't know how. In a world devoid of life, you bring color. In your eyes I see the light, my future, always and forever. I know I can't let you go. I'm in love with you, and now you know. I'm in love with you, and now you know. Thank you.
Good morning, everyone.
Good morning.
You'd be like heaven to touch. I wanna hold you so much. At long last, love has arrived. And you're just too good to be true. Can't take my eyes off of you. Pardon the way that I stare. There's nothing else to compare. The sight of you leaves me weak. There are no words left to speak. But if you feel like I feel, please let me know that it's real. You're just too good to be true. Can't take my eyes off of you. I need you, baby. And if it's quite alright, I need you, baby, to warm the lonely nights. I love you, baby. Trust in me when I say, oh, pretty baby, don't let me down, I pray. Oh, pretty baby, now that I found you, stay and let me love you, baby. Let me love you. You're just too good to be true. Can't take my eyes off of you. You'd be like heaven to touch. I wanna hold you so much. At long last, love has arrived. And I thank God I'm alive. You're just too good to be true. Can't take my eyes off of you. I need you, baby. And if it's quite alright, I need you, baby, to warm the lonely nights. I love you, baby. Trust in me when I say, oh, pretty baby, don't let me down now.
Shall I stay? Would it be a sin if I can't help falling in love with you? Like a river flows surely to the sea, darling, so it goes. Some things are meant to be. So take my hand, take my whole life too, for I can't help falling in love with you, for I can't help falling in love with you. I messed up tonight. I lost another fight. I try everything.
Yeah. Good morning, everybody. Can you hear me clearly right now?
Yes.
Yes.
Great. Okay, good morning, ladies and gentlemen. My name is Christina. I'm the head of the Bachelor program in Industrial Engineering, Universitas Kristen Maranatha, or you can call it like a Maranatha Christian University in English version. I would like to thank to all of you for participating in this event. I hope you are in good and healthy condition wherever you are. Although we have like in the middle of the situation of the pandemic era. And welcome to our collaborative seminar titled Decision Making in Industrial Engineering Methods and Cases. This seminar is held in the collaboration of the Industrial Engineering departments of three universities, Universitas Kristen Maranatha Bandung, Indonesia, or we can call it Maranatha Christian University in English version, and also the National University of Singapore, and University of Southern California, USA. We also have three honorable speakers here: Dr. Indah Victoria Sandroto from Bachelor Program in Industrial Engineering, Universitas Kristen Maranatha, Indonesia, and also Dr. Tan Chin Hon from Department of Industrial System Engineering and Management, National University of Singapore. And the last but not least, Professor James Elliott Moore, second Ph.D. from Daniel J. Epstein, Department of Industrial and System Engineering, University of Southern California, USA. Thank you for all of the willingness and the available time to share the knowledge in your expertise to us here. In the seminar, we will hear from our speakers about decision making in industrial engineering in methods and cases. It is really a great opportunity that we could gather here worldwide in only one Zoom room, and it is really amazing because until this morning, I count all of the participants here that registered online. We have like 537 participants here that come from several different countries like Indonesia, Philippines, Taiwan, Singapore, Malaysia, USA, and others. And they are students, also faculty members, and also employee of the some of the institution here. We could give ourselves a big applause for our diversity here. Maybe you can also give the applause like online with the reaction here. And right now, I would like to invite the General Secretary of the Universitas Kristen Maranatha, Indonesia. Please welcome Dr. Robi Yusak Talar, PhD, to give the opening speech.
Thank you, Mrs. Korok, and honorable speakers, colleagues, and ladies and gentlemen. On behalf of our rector of Maranatha Christian University, I would like to express my gratitude to all the presents, all the delegates here, and the participants, also the speakers in this event, the Industrial Engineering International Seminar. And I also want to give a warm welcome to our main speakers today, Dr. Indah Victoria Sandroto from Maranatha Christian University, and Mr. Chin Hon Tan, PhD from National University of Singapore, and also Professor James Elliott Moore II, PhD from University of Southern California. I think it reflects a good collaboration among us and also Maranatha and in US and also the University of Southern California. The system engineering apply the knowledge and also the creativity and the energy to make things better. And I believe all the good things can happen. And I hope in this conference will improve your problem solving by expanding your system thinking ability and increasing your understanding of the rules of decision making in the industrial engineering. And we can improve the system decision making process that required to solve our complex challenge in our organization. And I believe that all the participants will acquire a new skill and knowledge from this seminar. I will encourage all of you to take active part in this interesting discussion later. In closing, I'm very thankful for the committee for their work in this seminar. Thank you very much.
Yeah, thank you, Dr. Roby. Before you leave, maybe we can take picture together with the General Secretary and all of the speakers here and also the moderator. Yeah, I will make the spotlight first. Yeah, yeah, I think we are already here. Okay, great. Okay, maybe the committee can take the picture here. Okay, I will count 1, 2, 3 and give our big smile. Yeah, okay. 1, 2, 3. Okay, thank you so much. Yeah, thank you, Dr. Roby.
Welcome.
Yeah, and we will continue our event. Let us continue with the main event right now. And I would like to invite Mr. David Try Liputra, STMT, the faculty member of Bachelor Program in Industrial Engineering, Universitas Kristen Maranatha, Indonesia, as our moderator that will lead the seminar. Please welcome. Mr. David, I think you are in the mid mode.
Okay,
Still.
okay. Sorry, I forgot.
Yeah, it's
that
okay.
Okay, thank you, Miss Christina. Good morning, everyone. As Miss Christina has mentioned before, I'm David. I'm the moderator of today's seminar. I hope all of us are in healthy condition, and I am very happy to meet you all, even though only virtually. And I think that we all are so excited to participate in this industrial engineering seminar. So today's seminar will consist of 2 sessions. The first session is the sharing sessions from our speakers. We have 3 stunning speakers today. The first speaker is Dr. Indah Sandroto from Universitas Kristen Maranatha, or in English version, we can call Maranatha Christian University, Bandung, Indonesia, who will share about system dynamics dealing with complexity. And the second speaker is Dr. Tan Chin Hon from National University of Singapore, or NUS, Singapore, who will share about revisiting mean variance analysis. And the third speaker is Professor Dr. James Elliott Noor from University of Southern California, Los Angeles, USA, who will share about a critical review of Los Angeles Metro's 28 by 2028 plan. Okay, approximately 25 minutes are given to each speaker in this session. So for Dr. Indah and Dr. Tan, good morning. And for Professor Moore, I think it's good evening, since we have 13 or 14 hours difference here in Indonesia and USA. And thank you to all our speakers for joining us today. And in the second session, we have the Q&A session. So all participants are welcome to ask any question to our speakers via the chat box in the below section of your Zoom meeting application by first introduce your name and also your affiliation, so you will be recognized as well. And please do not forget to mention to which speaker your questions are addressed to. Okay, now we will start the first session. Before Dr. Indah will share about her presentation, allow me to introduce more about her background. Okay, so Dr. Indah now is the faculty member of Bachelor Program in Industry Engineering, Universitas Kristen Maranatha, Bandung, Indonesia. Her education background, she received her bachelor degree in Industry Engineering from Institut Teknologi Bandung in 1995. And then she received her master's degree in industrial engineering and management from the same university in 2001. And in 2004, she took the postgraduate diploma in management from Massey University, New Zealand. And in 2019, she received her doctoral degree in industrial engineering and management from Institut Teknologi Bandung, Indonesia. There are so many professional experiences from her. Some of them are in 2010 as supply chain management expert, distribution channel management, Directorate of Oil and Gas in the Indonesian Ministry of Energy and Mineral Resources. And in 2011 as supply chain management expert, distribution channel evaluation, Directorate of Oil and Gas, Indonesian Ministry of Energy and Mineral Resources. And in 2020 as project leader industry sector low carbon development Indonesia or LCDI initial implementation phase system dynamics Bandung bootcamp PT DAS Aviation Training Center. She also received many awards. The latest one is the grand recipient doctoral dissertation research from Ministry of Research, Technology and Higher Education. And she has published so many research articles in the field of her expertise. And her research interest is in system thinking, system dynamics, policy analysis, customer relationship management, and enterprise resource planning. Okay, for Dr. Indah, you are welcome to start your presentation. Thank you.
Thank you, Mr. David, for the opportunity given to me. I will share my slide. Is my slide PowerPoint can be seen?
Yes.
Thank you. Okay, thank you for the opportunity given to me. Thank you for all the speakers, Professor James Moore, Dr. Tan Chin Han, also General Secretary from Maranatha Christian University, Mr. Dr. Robi Yusaktalar, and also I see in the audience Professor Franz Mardi, my teacher in industrial engineering, Bandung Institute of Technology, and all audience that already give time for attend this virtual seminar. My title is System Dynamics Dealing with Complexity. My name is Indah Victoria Sandroto. I am from Industrial Engineering, Maranatha Christian University, Bandung, Indonesia. Okay, I will talk about three things. First, because this is industrial, we are part of industrial engineering, so I share a glimpse of body of knowledge of industrial engineering, and then move to basic concepts in system dynamics, and then a case taken from my dissertation. As we are familiar, the definition for industrial engineering is concerned with the design, improvement, and installation of integrated systems of people, materials, information, equipment, and energy, so many things. And the keyword is here integration. And we are equipped with knowledge and skills in mathematics, physics, social sciences, with principles and methods to analyze, design, specify, predict, and evaluate results obtained from such integrated systems. So from the body of knowledge, I took it from Institute of Industrial and System Engineers. There are 14 knowledge in industrial engineering, from first one, work design and measurement, operations, research and analysis, until 14 system design and engineering. And we can find system dynamics in knowledge number 2, operations, research, and analysis. And because systems dynamics is this simulation, and we can see the level of abstraction among the simulation modeling from discrete event, agent-based, and also dynamic systems and system dynamics. So from low abstraction or micro or operational until high abstraction, less detail, and macro level and strategic level, that is the system dynamics. So this is in levels and aggregating in, this is high abstraction, macro, and strategic. So we move to the basic concepts in system dynamics. The founder of system dynamics is J.W. Forrester. And in our daily life, this is very simple, and this is a classic example in system dynamics. If we turn on the faucet to flow water into a glass of water, so the flow of water fill the water, the glass. Actually, the level of water, it gives information to our eyes. Oh, it's getting full like that. And then it gives control policy to the hand, and then to turn on or off the faucet, and then also the flow again. So what we might think that we think the world as open loop. We receive information, and then we do action, the flow of water, and then result. This is an open loop, but actually, when we see the result, for example, water level, it gives back, it gives feedback, information about problem, give feedback. So this is actually a closed loop one. So this is the basic for system dynamics, and that's why J. Forrester and then developed the stock flow diagram to explain this phenomena. So stock is what we accumulate, like water level. It can going up and going down like that. So it is show behavior over time. And the stock will give, if we find, give information to the flow. So here in flow or rate, we compare the actual condition and the goal, and then do action. When we can explain the phenomena in something like this, so we welcome system dynamics, closed loop one, like that. So this is the simplest one of system dynamics model. So the foundation of system dynamics is closed boundary, closed boundary. And then there is level or state variables representing accumulation within the feedback loops. This is the level or stock. And then the rate or flow variables representing activity within the feedback loops. And this is the rate representing give what change, what activity to change this accumulation of the level or stock. So here in rate or flow, there is goal, and then also observed condition, actual condition, and also discrepancy, and also action taken based on the discrepancy. So system dynamics want to explain in endogenous point, from the endogenous point of view. It means it wants to explain why something that we see that is the focus our interest, give behavior over time. So related to our seminar about decision making, so a simulation model, in this case system dynamic model, is based on explicit statement of policies or rules that govern decision making in accordance with conditions that may arise within the system being modeled. So this one is flow or rate, and there is a policy or rule that govern this, the decision making, and this is the decision making process consists of three parts: the desired, the actual, and the corrective action. The desired are the goal, the actual condition like the water level in the example, and the corrective actions. So this one is one of the flow contained with three parts in decision-making processes. And then we already see one stock as the simplest form of system dynamics model. So we move to the complex ones. How about is the stocks are many, and the stocks have connected each other. We cannot, with our mental model, with our thinking, to comprehend all these complex things. So that's why we need computer simulation, because with the help of computer simulation, the computer help to see the accumulation over time and give information to us how the stocks, the system behave. And then this information used in system dynamics from mental database, from the reality, and then to written database, and finally we make numerical database to put or to in the simulation model. So this is using software, for example, FanSim or PowerSim. And then so we come to the definition of system dynamics. It's actually comes first from industrial dynamics. So system dynamics is the study of the information feedback. Feedback, it means closed loop. Characteristics of industrial activity to show how organizational structure, amplification in policies, in the flow, and time delay, because there is discrepancies between decision and action, interact to influence the success of the enterprise. It treats the interactions between the flows of information, money, orders, materials, personnel, and capital equipment in a company, and industry or a national economy. So for we as industrial engineer, we can apply the system dynamics in a company or an industry, and also I saw many application of system dynamics. My friends give bring develop model about ecotourism, something like that. So this is system dynamics is a complex interlocking network of information channel. Complex because so many things. We have to see how we see the connection, the interrelationship, the interaction between the resource, something like that. So the popular one for the system dynamics tool is stock flow diagram and causal loop diagram. With stock flow diagram, we from one level, it will change by the rate, by the policy to the next level. And we put the equations and the parameters like that. to the software. And also we have causal loop diagram. This is explained about the difference if it moves in similar direction. Increase in A will increase in B, and increase in B will increase in A. So this is reinforcing loop. But if it moves from with in the opposite direction, A increase in A will increase in B, but increase in B will decrease A. We say this one balancing loop. So system dynamics, if we see complex problem, we see the events and it has the pattern, and then the underlying structure and the mental model. We in our daily life only see event, or maybe we can recognize the patterns. But thank God for this system dynamics, it can explain what is the pattern systemic structure. In here, systemic structure, we can develop stock flow diagram and causal loop diagram and the pattern. For example, in Peter Senge, fifth discipline, the pattern already explained the archetype to explain about this, what is the pattern and the paradigm, the mental model by root cause analysis. Okay, why we need to do the system dynamics model? After the problem, there are leverage points. These are places within a complex system, a corporation, an economy, and a city, an ecosystem where a small shift in one thing can produce big change in everything. So by mapping the process, and we know we can see and we can make scenarios. So what is the leverage point that we can do from the changing the parameters until the power to shift a paradigm like that? Okay, we come to the third one, the last one. My dissertation title is Modeling Balancing Acquisition and Retention Accommodating Capacity Expansion in a Fiber to the Home Broadband Service Provider. So this is, I make a case in a telecommunication company, FTTH, broadband service provider, and this is acquisition, retention, and capacity expansion. The introduction, this is from company strive for loyal customers and grow CRM with two main activities. Customer acquisition means how we change, company make a strategy to change the prospects to become the first customers. And for customer retentions, how with the existing customers company have, we keep how the customer to keep buying to the company. And the matrix is customer equity. This is in simple form is the present value of the total transactions of customers during a certain period of time with the company. So of course, the company wants to maximize the customer profitability. Based on literature study and preliminary study to a telecommunication company, the company has capacity problem. At first, it is the capacity is limited, and then capacity after that they add capacity, so become huge capacity, but the problem is does not stop. So in this study, the study wants to develop a model of balancing acquisition and retention in customer relationship management process that could increase customer equity in a certain period of time. So this one, we want to see the behavior and take into account activities of first, capacity expansion, because if company experience not enough capacity, that will be low sales. Company also need to have budget for acquisition to attract prospect to become first customers, budget for retention to keep the loyal, the existing customers to keep loyal and keep buying. And also there is, I identified there is a synchronous activity to synchronize between acquisition and capacity planning, because it happened, for example, the demand is in south of Bandung, but the capacity installed, this one, the fiber that must be extended from underground or using cable poles like that. So they, for example, they extend it, they build it, they install it in north of Bandung. So it's not synchronized. And then synchronization between acquisition and retention, because, for example, company wants to give promotion to attract prospects to become first customers, but the existing customer cannot participate in that promotion, so they stop the subscription and become the new customer, and actually that's not the aim. For example, for activities number 1 and 2, that is actual conditions, and activity number 3, 4, and 5, when it was studied, it was the proposed condition because the company not yet done that, or did it in small portion. So from the interrelations like this, I developed 7 research propositions. Proposition 1, 2, 3, 4, 5, 6, and 7, and the activities, existing capacity, and budget allocation. For allocation, this is actual condition. And then for proposition 1, actual condition, and we add activity budget allocation for retention. And then for proposition 2, from actual condition, we synchronize between acquisition and capacity planning. And then in proposition 3, because we add 1 activity each, I want to compare which one is better. And proposition 2 gives a better customer equity, it means profit, than proposition 1. For proposition 4, with the condition, we have 3 conditions, and then add 1 more activity, in this case synchronization between acquisition and retention. And for proposition 5, synchronization between acquisition and capacity planning. And then we compare again. Proposition 5, this one gives a better customer equity than proposition 4. And of course, the proposition 7, that with all the 5 activities, company will give these activities will give a better the best customer equity. So this is the submodels, and then this is the stock flow diagram developed from the stock population, and then we think what is the company's potential market, and then the capacity submodel, and then from the company potential market, so we can identify the decision-making process here to invest and to add capacity, Let's say this one is capacity in the telecom communication company, the office, and it must be installed to the point where the fiber to the home near the customers. So there is activity capacity activity rate, and also the factors to make decisions. For acquisition and retention submodel, there is the potential customers, first-time customers, active customers, and also from potential customers, there might some lost potential customers. From first-time customers, there is a rate for lost customer from first-time customers, and from active customers to there is a rate for lost customers from active customers. So there's also how to change the potential customer to become the first customer, and then from the first customers to the active customers. And then also we have case discipline here with the behavior. So this is the level, the square, the level with total revenue from active customers and first-time customers, and also expense for marketing, for operations, for capital, and for marketing also. It is for retention and acquisition. So it's give a picture of the process in the telecommunication company about the process and the decision making made in the company. So for causal loop diagram, this one reinforcing, there is a reinforcing for if we have first time customer more, and then also become more word of mouth, and also active customer will become more word of mouth, and will add more first time customer and active customers. And also for capital, the more investment in capital will increase word of mouth, customer effectiveness, remarketing effectiveness, and give also reinforcing. And also for operation, will support the the effect of word of mouth, customer effectiveness, and remarketing effectiveness. But there is also balancing loop in expense. The more expense in marketing, operations, capital, and the cash will decrease. And also the balancing for marketing effect, the more adoption from marketing, the less the potential customers. Also word of mouth effect on market saturation. Okay. So finally we come to the end. Sorry, more than 25 minutes. So this is the equity and the result of the scenario for actual condition, proposition 1. Actual condition, this one, and then why this is reduced, because we make assumption that fixed price, but cost is the increasing, and based on price, average price. And this is we add the activity add to retention, this one to actual condition, and give budget allocation for retention, is proposition 1, and then proposition 2, it gives a high impact for the customer equity by synchronization, acquisition, and capacity planning. And then proposition 4 here, proposition 5, and proposition 7. So this one, according to the adding of customer equity from actual condition, proposition 1, 4, 2, 5, and 7, but we can bypass it. From actual condition, we have capacity planning and allocation for acquisition. We directly make synchronization between acquisition and capacity planning. because it gives high impact. Why? Because this is a high-tech company, and usually people, even they don't less maintenance for retention, but they keep loyal. But if we don't synchronize in acquisition and capacity planning, there will be lost sales. So proposition 1, and then to proposition 5, and to proposition 7. So I close this presentation with the sentence from the Peter Senge. At the heart of a learning organization is a shift of mind from seeing ourselves as separate from the world to we are not separated, we are connected, to the world. From seeing problems as caused by someone or something out there to seeing how our own actions create the problems we experience. Thank you. Sorry for more than 25 minutes. Thank you.
Okay, thank you for Dr. Indah for your sharing about how to deal with complexity with some diagram such as causal loop diagram, stock flow diagram, and other system dynamics models. Now we will continue to the second speaker. So Dr. Tan received his bachelor degree in industrial and system engineering from National University of Singapore in 2005, and he received his master degree in industrial and system engineering from University of Florida in 2009, and his Ph.D. is in industrial and system engineering, University of Florida in 2012. There are so many positions held by Dr. Tan, some of them in 2005 until 2006 as reliability engineer, mechanical and civil department, Shell Eastern Petroleum Singapore. In 2006 until 2007 as academic staff, Center for Science and Mathematics, Republic of Polytechnic Singapore. In 2007 until 2012, is as graduate assistant in Department of Industrial and System Engineering, University of Florida, USA. In 2012 and until 2018 as assistant professor of Department of Industrial and System Engineering, National University of Singapore. And from 2018 until now as assistant head administration and external relation of Department of Industrial and System Engineering, National University of Singapore. There were so many rewards received by Dr. Tan. Some of them are as the teaching awards from the Faculty of Engineering Commendation List in 2016, and also Best Paper Award in Engineering Economy Division in 2013, Industrial and System Engineering Research Conference in San Juan, Puerto Rico. And some professional service by Dr. Tan is as the area editor from Capital Investment Analysis in 2016, and also as editorial board member of the Engineering Economist from 2014 and until 2017. Dr. Tan has published so many research articles and also books in the field of his expertise. Okay, so for Dr. Tan, you are welcome to start your presentation. Thank you.
Okay, thanks David for the introduction. So let me just share my screen right now. Okay, and so I believe you should be able to be seeing my screen at this point in time. Let me just get everything set up over here. Okay, and so as mentioned, thanks for the introduction. And today, the topic that I'll be sharing with you is essentially going to be on revisiting mean and variance analysis. So if you know what mean and variance analysis is, then hopefully I'm going to shed some insight on this topic to you. If you do not know, then no worries. I'll try my best to highlight to you why we are interested in this over here. Okay, and so so I want to thank our first speaker for the for the presentation. Indeed, it was very interesting. I think one good point is she has highlighted how the real world system is going to be very complicated. And so the complication comes in terms of the relationship between the various components and the interaction, the dynamics within them over there. In fact, and as David has introduced, upon my undergrad graduation, I first went to work in the oil refining industry. And that's when I realized that real world problems are very complicated, right? Because of all these relationships and so on. And so that's when, I decided to study a bit more. I came back into the academic field over here. And so what I want to look at actually is going to be a different dimension over here as to what can actually complicate matters. So I think our first speaker has given us a lot of insight as to why real world problems are complicated. Unfortunately, I'm not going to use a real world example, but I'm just going to use some simple toy examples over here to highlight why decision making under uncertainty is also going to be another dimension of what complicates matters over there. Okay, and so very quickly, just think about it. If we have to decide something if we have to decide without any uncertainty, some problems can be very easy to solve over there. So for example, if I was to ask you, would you prefer $5 or would you prefer $100? What would be your answer? I think this is very straightforward, right? More is always better, right? So it can't hurt you to have $95 more. So obviously $100 is going to be better than $5. Nothing complicated over here. But what happens is that if right now I have to choose between $100 and maybe a 50-50 chance of losing, let's say $200 and earning $300 over here, suddenly this decision becomes a bit more complicated over there. And in fact, it's even complicated by the fact that perhaps you have individual A. Individual A will perhaps prefer to just receive $100, whereas individual B may prefer to go for this gamble over here. Okay, and so what I hope to share over here is that even for very simple problems, the fact that there is uncertainty involved is actually going to complicate matters over there. And what we observe is also that the complexity increases exponentially with the number of choices. So if I had to choose between A or B, that still seems to be a fairly simple problem over there. But if you have to choose between 20 different choices where the returns of each of this choice is uncertain, then that becomes increasingly difficult. You blow that up to just 40, the complexity actually increases exponentially over there. Okay, and in fact, we know this. There's quite a bit of study in the psychology area where basically we've seen that when people are faced with a large number of choices, very often they are going to procrastinate. So if you ask them, do you prefer $5 or $100? They are going to straight away make the decision. They take the $100 and then they leave. You ask them to choose between A or B over here, whether you want a fixed reward or uncertain reward, the problem becomes more complicated. So they need time to think over there. And the problem with thinking is that in the business world, time is money, right? So essentially, you're wasting your time resource over there. But an even bigger problem over here is that when people think, they may actually just put it on the table, and then 1 month later, they forget about it. And so in effect, what happens is that they have foregone that investment opportunity over there. And even if people do go ahead to make that decision and decide what they want to do, we have found out that people tend to actually be less satisfied with the decision that they essentially make over there. Okay, and so let me just apologize. I should erase all the ink over here. And so just to highlight one example over here. So there are these two social psychologists, and then they actually got their undergrad students. They did the experiments on them, and so essentially for their class, they gave an optional assignment. If you did it, you get extra grades for it, but it's not necessary for you to do it over there. And so they kind of divided them into two groups. So for one group of students, they presented 6 different topics to them, and they had to choose one of these 6 topics to do. And for the other group of students, they had they had to do one of 30 topics over there. Okay, and so what they observed is that for the first group, 74% of the students actually went ahead to do this optional assignment. Whereas for the second group over there, only actually 60% of the students went ahead to do the assignment. And so this is essentially what we mean over here, that people tend to procrastinate and then they actually decided that, I don't even want to make a choice. I'll just not do anything over there. Okay, and so what I hope to share with you, I hope I've convinced you that making decision under uncertainty is going to be challenging. And especially when you have a large number of choices over there, then this becomes a difficult problem that a lot of people face in practice over there. And so what I hope to share with you over here is, are there ways that we can help our decision maker to reduce the number of choices that he or she would have to consider? Okay, and so very quickly, I just want to talk a bit about decision under uncertainty. So I'm assuming that most of you are somewhat familiar with random variables. So I'll quickly just give this example. So suppose we let X denote the outcome of a six-sided roll die. So outcomes of 1, 2, 3, 4, 5, 6 equally likely. Suppose I gave you a gamble. We will roll the die, and depending on the outcome of the die, I will give you your payout over there. And let's say over here, the gamble costs $2. Would you want to participate in this gamble over here? So the very standard approach that we have is then it depends on what is the expected payout, right? What is the expected value of X over here? So if you compute the expected value of X is going to be $3.5. So the expected payout of this gamble is $3.50. So since it only costs $2 for us to participate in this gamble, we should actually go ahead and participate in this gamble, simply because the payout is the expected payout is higher than what it is costing us to enroll in this gamble over there. Okay, now next, so that's a pretty straightforward way of doing things, but then there are going to be some limitations. And so what I want to share with you next is going to be a very classical problem called the St. Petersburg paradox. If you've heard of it before, just bear with me. I'll go through this quickly. If not, I hope this is going to be of interest to you as well. So now imagine this second gamble over here, where we have a fair coin. So it's a 50% chance heads, 50% chance tails. Okay, we're not going to worry about the case where it lands exactly, on its rim so that it's neither heads or tails. Okay, so 50-50 chance. And then I'm just going to keep flipping this coin until I obtain heads. Okay, and so I'm going to let X denote the number of coin flips. So the possible values that X can take is going to be 1, 2, 3, 4, 5, all the way to infinity over there. So for example, I flip the coin. If at the first coin flip, it's tails, I will flip it again. If the second time round it's still tails, I'm going to flip it again. If at the third time round it's heads, I'm going to stop. And under that situation, X is going to be 3 over there. For this gamble, your reward is going to be 2 to the power of X. So for example, if X is 3, then I will give you $8 for this gamble. My question over here is how much are you willing to pay? Or for example, if I charge you $5,000 to participate in this gamble, will you want to join this gamble over here? So if we go back with our previous reasoning, then it really depends on what is our expected reward, right? What's the expected value of 2 to the power of X over here? And so for us to see that, essentially we just need to kind of find out what are the possible rewards we're going to get. You are going to either get $2, $4, $8, $16, and so on. What's the probability that you'll get $2? It's half, right? Which means that in the first flip, you actually get heads over there. What's the probability that you get $4? It basically happens when the first coin flip is a heads, the first coin flip is a tails, and the second coin flip is a heads over there. So that's half times half, and that's 1/4, and so on. And so I hope you can see from here where I'm trying to get at. The expected reward of the St. Petersburg paradox is infinitely large over there. But then nobody, so far, at least so far of all the people I've spoken to, nobody would be willing to pay $5,000 to participate in this gamble over here. Okay, and so there is some limitation in terms of that simple rule that we have where we make decision under uncertainty based on just the expected value alone. You can see over here, that's not going to make sense, right? So I'm not going to pay $5,000 to participate in this gamble, even though the expected reward is infinitely large. So what's going on over here? So what's the issue? Um, there are actually going to be a lot of issues over here. So let me just talk about just one way that we can try and resolve this. So one way you can look at that is that for somebody for somebody with only $1, the additional dollar that they receive is going to be very valuable to them because it doubles their wealth. But for somebody who already has $1 million, that additional dollar to them actually doesn't add as much happiness. Okay, so it's not going to be worse off, right? Having one additional dollar, it's always not going to be worse off. In the worst case, you can just throw away that dollar, right? But then it's just that the additional happiness that it brings along is not going to be as great as somebody who only had $1 to begin with over there. And so what economists and also decision analysts, decision scientists have proposed is that when we think about the happiness or the utility associated with our wealth, we shouldn't be thinking that it's going to be a linear relationship, but it should actually be a concave relationship over there, where the more you have, then the increase in happiness actually decreases. And so one function that is frequently used is going to be the log function over there. Okay, and so let's say if I use a log function, then the utility, or once again, you can think of utility or happiness as somewhat of the same thing over here. Then the utility associated with $2, I just apply ln 2, is just 0.693 over here. The utility of $4 is just 1.386. The utility of $8 is just 2.079 over there. And using this, I can also find out the utility and the expected utility of my St. Petersburg paradox. In this case, rather than getting $2, the happiness associated with it is ln 2. And so after I work it out, the expected utility of the St. Petersburg paradox is going to be 1.386 over here. Okay, and so in this very toy example, the numbers actually work out very nicely. So if you observe 1.386, it's a number we've seen previously, right? It's actually just this number. So in fact, the expected reward, the expected utility of the St. Petersburg paradox is essentially the same as the utility associated with $4 over there. So in essence, what it means is that if I'm described by the log utility, then I will participate in the St. Petersburg paradox if you charge me less than $4. But if you charge me more than $4, then I would actually, I would prefer to just keep my $4 rather than to participate in the St. Petersburg paradox over there. Okay, and so this is where we illustrate how through the use of a utility function, which better describes our attitudes towards wealth, is able to then resolve the paradox that we've seen over there. Okay, but the question over here becomes, but what is the utility function to use over here? Because it differs from different people to different people, right? So some people may agree with this. They say that, yeah, I will only pay at most $4 for the St. Petersburg paradox. But if you talk to people, there are people who are willing to pay $8, there are people who are willing to pay $6, $7, and so on. And so for them, we need a different utility function to describe them over there. Okay, and so how then do we kind of go about describing all these people? So there are ways that we can estimate the utility function of our decision makers. And typically we do that by asking them a series of questions. And based on those questions, we estimate out their utility function over there. But there are going to be a lot of issues involved. And in most cases, you can think about it that we are only approximating the utility function of our decision maker. And we do not know the true utility of our decision maker over there. Okay, and so even though we have a very nice decision model over here, there is going to be a certain amount of estimation error, a certain amount of inaccuracy in terms of our final prediction. So in the interest of time, I don't want to go too much into that, but of course, if you're interested, we can always talk about this subsequently. So, but let me now start to move towards think a bit more about our expected value and how it helps us in our decision making. So let's think about this where you have two investments, X and Y over here. And if I told you that the expected returns of investment X is 50,000 and the expected returns of investment Y is $50, and if I told you that they are guaranteed zero losses, so this is a guaranteed zero loss investment over there, where you will definitely not lose money, but it's just how much you gain over there. So over here, I only tell you their expected values. I don't tell you anything else. We know that the decision is clear to a risk-neutral decision maker. When I say a risk-neutral decision maker, essentially I mean somebody who is described by a linear utility function. Because for somebody like that, basically they're just going to go for the one with the higher expected value. But even if our decision maker is not risk-neutral, that means they are described by some non-linear utility function, which most people are. We can see that this decision is still going to be clear to most individuals over here. So just think about it. If somebody came to you with two investment opportunities and say that, oh, okay, they are guaranteed to not lose any money under these two investments. The first one has an expected value of 50,000. Second one has an expected value of $50 over there. Do you want to invest in X or Y, or do you want to think about it? But if you think about it, somebody else might come along and grab this opportunity. If you're faced with that situation, I think most people will just go ahead and grab X, right? Without worrying too much about, well, what is the standard deviation, what is the third moment, and so on of all these two distributions over there. Okay, so when you think from that perspective, I hope it's obvious to you that this decision is actually going to be clear to most decision makers, even if your utility function is not linear, even for somebody with a concave utility function over there. And so we published a paper in 2017 where we tried to explain why that is so. Okay, and basically our result over there is very straightforward, where basically we showed that it is possible to prove that the expected utility of X is greater than the expected utility of Y for all non-decreasing utility functions where the ratio of its marginal utility is less than the ratio of these two over here. So why I have 1,000 over here? 1,000 is essentially just the ratio of the 50,000 and 50. 50,000 divided by 50, that's 1,000 over here. Okay, and so essentially what we have proven in our result over there is that when faced with this choice, the expected utility of X is definitely going to be greater than the expected utility of Y, so long as our gradient doesn't deviate by more than a factor of 1,000. On top over here, this is basically the largest gradient of your utility function. And at the bottom over here is basically just the smallest gradient of your utility function over there. Okay, and so to put it intuitively, basically, the greater the difference between X and Y, then the larger the deviation that is allowed from linear utility, such that X is still going to be preferred over Y over there. Okay, and so based on this result, that's how we kind of explain that in this situation, actually the decision can still be clear to most decision makers. Because even though you do not have you're not described by a linear utility, but because the difference between X and Y is so great that this decision remains clear even for a lot of utility functions that deviate from the linear utility. And so the larger the ratio between these two, then the greater the set of decision makers we can cover over them. And so with that, I want to move towards mean variance decision making. This is used very often in the financial investments. So we've talked about how expected value is going to be relevant in terms of determining preference. The other data that is often available is going to be the standard deviation or the variance over there. And having a lower standard deviation basically means lower dispersion or lower uncertainty. And so for most people, they just equate that as having lower risk. And so typically you choose investments that have higher expected returns and lower standard deviation over there. And in fact, there is a very nice result that if X and Y are normally distributed, if your returns are normally distributed, then we can show that the expected utility of X is bigger than expected utility of Y across all non-decreasing concave utility function. Then under this situation, that's why this rule actually makes sense over here. So long as we know our decision maker is described by a concave utility function, then we know that this decision maker would prefer X over Y if X actually exhibits this attributes over there. Okay, so this is a well-known result. It's been around for quite a while. Basically, it follows from the fact of second-order stochastic dominance. Okay, and but the question over here is what happens if X and Y are not normally distributed? Unfortunately, in real world, there are a lot of problems where they are not normally distributed, right? So how do we kind of tackle this issue over there? All is not lost because what happens if we can, if our decision maker is described by a quadratic utility function. So it can take a form like that. And so by having a form like that, we would then be able to describe some concave utility function over there. And if our utility function is quadratic, the expected utility of our random variable can actually be expressed as a function of just the expected value and the variance over there. Okay, I think this should be a well-known result. Basically, expected value of x and expected value of x squared, right? And expected value of x squared is just a function of expected value of x and variance of x, that's why. Okay, and so given this observation, we realize that x and y, that means if our decision maker is described by a quadratic utility function, then we can also infer his or her preference based on just the mean and variance of x and y alone over them. Okay, and so this mean variance decision-making paradigm is actually very well grounded in some mathematical principles over there. Okay, but the challenge that we have over here is that, but what happened if our decision maker is not described by a quadratic utility function over there? And I more specifically recall when I talk about how we try to estimate the utility function of our decision maker, there are going to be a lot of issues involved. Okay, and so you can just take it that in most cases, we do not know the true utility of our decision maker over there. So how then can we kind of resolve this? And so this is where I hope to just go back to that simple two investment example I've highlighted, right? Where basically we have already shown you that we have a result that allows us to account for deviation from linear utility. And basically what we say is that so long as the expected value is a lot larger, then we can actually cover for a lot of utility functions, even those that deviate from linear utility. And the bigger the difference, the larger the set of utility functions we can cover over there. And so what we have is that we are going to have a similar result for quadratic utility functions as well. And so essentially, this actually follows from essentially our first result. So this is just corollary 2 of that paper of ours. And so essentially what happens is that if we can estimate the utility function of our decision maker, and it takes a quadratic form over here, then what happens is that we can then prove that the expected utility of x is going to be bigger than expected utility of y for all utility functions that are in the neighborhood of our estimated utility function over here. And at the same time, the size of this neighborhood is going to depend on the ratio of those two estimated expected utility. The larger the difference between them, it means that the larger the set of utility functions, we are able to guarantee that preference. And so in this case, basically, it means that we are able to allow for larger deviation from quadratic utility function. In fact, the result is a bit more general. It allows us to deviate from any utility function. But for the purposes of this presentation, I think we can just limit ourselves to quadratic utility functions over there. And so with that, basically, I've come to what I hope to share with you, which is our initial problem. How can we help to reduce the number of choices presented to our decision maker? And what I hope to share with you is this idea of a mean variance screening over there. Okay, and so the first thing that we want to do is that when you're faced with a lot of choices over there, A, B, C, D, all the way to Z, then the first thing that you want to do is first estimate the utility of a decision maker, making use of a quadratic utility function over there. And once you have the estimated utility function, the next thing that you want to do is you want to compute the mean and the variance of each of your investment opportunities. And then given that you have the mean and the variance of each of your investment opportunities, you will then be able to compute the estimated utility of each of those investment opportunities over there. And finally, you can just go ahead and prune away those that are unlikely to be chosen. So very quickly, just an example. Let's say I have 4 investments. I estimate the utility of my decision maker. I compute the mean and variance. From there, I compute the estimated utility over here. Under the situation, estimated utility of A, B, C, and D, let's say it's 1,510 and 1. Then under this situation, we know that estimated expected utility of A is a lot larger than C and D over here, right? In fact, it's about 1,000 times and 100 times larger over there. So what we can do is that we can say that essentially our decision maker only needs to consider the first 2 choices over here and can just eliminate away these 2 over here. Okay, and so this is basically just a very simple way that we can go about to eliminate choices for our decision maker. There is a caveat over here though, which is that this example I've given over here is actually based on the fact that we have an assumption, which that all our investments are guaranteed 0 losses. Okay, in our paper, we do relax this assumption that we allow for losses to actually occur. But for the interest of this presentation, I didn't want to complicate things, okay? And so this example I've given over here at the end is actually based on the assumption that all these are investments that are not going to lose money. Okay, if losses are potential, if losses are possible, then it is still possible to do mean variance screening. It's just that the procedure will be a bit more complicated. But I think that we do not have at least I don't think that in the 25 minutes I will be able to cover that. Okay, and so I think I probably run out of time. But we see a question: can we apply pairwise comparison for the mean variance? Yes, we can, but I'll probably leave it to the Q&A. I'll leave it to our moderator for us to handle that. But thanks for the question. And then, so we'll get to that soon. If we don't, feel free to just drop me an email and then we can take this offline. Okay, so in a quick summary, predicting preference under uncertainty is going to be challenging. Okay, but in some cases, the preference can actually be clear. I've given some toy examples over here to illustrate that point. In the finance world, we have this mean variance rule, where basically we can actually identify which is the best decision based on the mean and the variance of our investment. The problem is that very often the underlying assumption is violated. Under those situations, we may not be able to accurately predict the preference of our decision makers. But I think that the biggest contribution of our work over here is that we've highlighted that even though you cannot use it for predicting the preference of the decision maker, you can still use it for screening purposes. And screening, as I've mentioned at the beginning of my slides over here, it's very important because it really simplifies the decision task over there. Okay, and so I think that was the main contribution of our work, which was basically just extending mean variance analysis to say that even though you cannot correctly predict the preference, it is still going to be a very helpful screening tool. And there's going to be a very nice mathematical foundation explaining why that is so. Okay, and so very quickly, I have some references over here. I believe the slides will be shared with you all. So as mentioned, thanks for the problem. I'll be happy to take it if we do have time, but I think I should hand it back over to our host, David.
Okay, thanks to Dr. Tan for your sharing about how to make decision under uncertainty condition using the mean variance analysis. So now we will continue to the third speaker. Professor Dr. Moore is a professor of industrial and system engineering, public policy, and Management and Civil Engineering. He received his bachelor degrees in Industry Engineering and in Urban Planning from Northwestern University, his master degree in Industry Engineering from Stanford University, his Master of Urban and Regional Planning degree from Northwestern University, and also his Ph.D. degree in Civil Engineering from Stanford University. He specialized in transportation engineering, transportation system, and other infrastructure systems. He joined Northwestern Civil and Environmental Engineering faculty in 1986 and joined the USC in 1988. He became chair of the Epstein Department of Industrial and System Engineering in 2004, serving until 2010. He served as Vice Dean for Academic Programs in the Viterbi School of Engineering from 2011 until 2017. He has served as President of the Institute for Operation Research and Management Science, or INFORMS, Transportation Science and Logistics Society, and also President of the Institute of Industrial and System Engineers, or IISE. So for Professor Dr. Moore, you are welcome to start your presentation. Thank you.
Thank you. I just had to remember to unmute. Those were great talks. I really enjoyed both of them. But let me see if I can share well here. Okay. All right. So let me fire up my file and we'll see what we can get. Can everybody see that?
Yes.
Wonderful. Thank you. Right. So I'll try to make up a little bit of time here. I like to apply industrial engineering techniques to public sector problems. There are a number of reasons. One is that public sector projects have got very large budgets associated with them. So there's a lot at stake. And then simultaneously, there's no residual claimant in the public sector. There's nobody to go broke if a bad decision is made. There's nobody to get rich if a good decision is made. As a result, we get circumstances where we've got some very large projects subject, frankly, to some very mediocre decision-making techniques. And I focus a lot on transportation systems. The Los Angeles Metropolitan Transportation Authority is planning on expanding our rail transit system. Our rail transit system is not very old in its current form. The first line we're currently using only went into service in 1991. It's been growing for the past 30 years or so, 30 years plus. And we're planning on spending considerably more money. This odd title, a review of Metro's 28 by 2028 plan, refers to a financial plan that the Metropolitan Transportation Authority has in place to increase a set of 20 projects currently funded under Measure M, our most recent sales tax measure, to a set of 28 with the objective of completing these by the 2028 Olympics. So it sounds good, but in truth, if you look at the projects involved and the timelines involved, none of them would be done by the 2028 Olympics. So I'm reading everything here with a bit of skepticism, everything Metro publishes. The work that was done here was founded by the Reason Foundation primarily, a little bit by the Institute of Humane Studies. I've got a co-author I should mention, Tom Rubin. Tom is the founder of Deloitte and Touche's transit consulting practice. He's currently an independent consultant. He was the treasurer and controller of the Southern California Rapid Transit District. I've described him as the forensic accounting equivalent of a cadaver dog. So he knows not only where all the bodies are buried, but where the shovels were purchased to bury the bodies. And he's just great to work with. He's fabulous with data, and he's very patient with me. And I owe him a lot for the joint work that we have done. And it is a pleasure to be back in touch with my friends and colleagues from Maranatha Christian University. This is always a pleasure. So I was looking forward to this evening's presentation quite a bit. But that's Dr. Christina and me, and we had a good time on her visit. The LA context. I think in the interest of time, I'm going to skip some of this. I'll jump to the bottom point. The economic and demographic changes that amplified the demand for public transit in Los Angeles continued in the 1970s and 80s. Southern California Rapid Transit District boardings, and those are bus boarding, increased 100% between 1970 and 1980. These sources of change still operate. That is, there is still fairly intensive demand for transit in Los Angeles. That demand remains strong, and LA's transit system is large and vital for the local economy. And I wish we were making better decisions about how it's managed, which is part of what this paper is about, because what that system does, especially for low-income groups in Los Angeles, is really extremely important. Metro is the Los Angeles County Metropolitan Transportation Authority. Used to be called MTA, now is conventionally known as Metro. It is the surface transportation planning and funding agency for the most populous county in the United States, and it operates the nation's third largest public transit system. We tend to think of Los Angeles as an automobile, at least US audiences tend to think of Los Angeles as an automobile intensive place, and that's true, but transit has always been a big part of our urban fabric, and it provides a great deal of mobility to specific segments of our society. And it's actually a very large system that, frankly, is not being managed as well as it should be to deliver the service that Los Angeles residents deserve. I describe somewhat jokingly that Metro is the best funded state agency best funded local agency, pardon me, in the history of local agencies. But a large share of Metro's funding, about a little under 60%, comes from 4 half-cent sales tax measures that were passed by Los Angeles voters over the years, beginning in 1980, propositions A, C, J, and M, and then an additional 1/4 cent State Development Act sales tax that applies to all counties statewide and was passed at the state level. Those revenues accrue to MTA along with revenues from these other 4 measures. In February of 2019, and this work was all completed roughly the time the pandemic began, so I haven't had a chance to talk about it much. And if it looks a couple of years out of date, it's because the world has been on hold for the last year. The MTA board provisionally adopted the financial element for this 2028 plan in February of, 28 by 2028 plan in February of 2019. The plan calls for a completion of 28 major transportation construction projects totaling $42.9 billion prior to the 2028 Olympics. Metro staff projects that $26.2 billion of that $42.9 billion is the additional funding needed to accelerate 8 projects for completion by 2028. The original Measure M, that most recent sales tax measure, called out in its ballot language 20 projects that it would pay for. It can't really pay for all of them, but the thinking is that somehow this agency can find funding sources to accelerate not only those 20 projects, but 8 more that currently are unbudgeted, and frankly, they can't. All right, quick trip to an alternative universe. This is actually kind of important. Fundamentally, transit, Metro included, is a form of wealth transfer. This is in the US. It's not the same internationally, but transit in the US is a wealth transfer. It's an attempt to make sure that everyone is served with at least a minimum degree of mobility, no matter what your income is. So low-income households have an opportunity to participate in the economy or experience a little bit of higher culture with greater mobility than they would otherwise be able to afford. Standard practice is to heavily subsidize the producer of transportation services and shield him or her from competition. So if I wanted to give up my career as a faculty member at USC and buy a van and go into the transportation business, I could rove or I could sell subscription services. I'd quickly find myself incarcerated because it's illegal to compete with Metro. They're a franchise. They're an exclusive right to serve coupled with an obligation to serve. Transit fares are not market prices. They don't index scarcity. So The fare box, frankly, is almost irrelevant to Metro. Metro says fares cover about 10% of their operating costs. I don't believe that, frankly. I think the value is lower. They do a lot of creative consulting. That is, they tend to move a lot of bus operating costs to another location in their accounting system. So they appear to be covering more of their costs with fares. There's talk of a zero fare in Los Angeles, and we may go to that. There are some places in the US that have zero fares. Who knows, maybe one day we'll see a negative fare. If you get on a bus, you get a coin. I mentioned before, there is no residual claimant in public transit. As a result, misallocations of resources are inevitable. Transit property growth comes from acquiring tax revenues, not delivering services riders want and are prepared to pay for. So all organizations exist to grow. And if we look at the public sector and the private sector, we notice there are different rules for that growth. In the private sector, organizations grow by controlling costs, configuring bundles of goods and services that people want to bid for. In the public sector, if you control cost, all that means is you'll have less money next fiscal year, and that's not a very good growth strategy. Instead, what some agencies will do, and Metro does, is to hover right at the edge of bankruptcy, because that is a winning growth strategy. It positions agencies, Metro in particular, to place continuing calls on public resources. The message is, tax yourselves so that we can finish the rail system we're building for you, and your neighbors will use it and decongest your road. You will have your road back. Well, that's specious. You can't really build a system that only appeals to everybody except you. If it doesn't appeal to you, it won't appeal to them. Ideally, instead, rather than focusing on subsidizing the producer very intensively and taking the market discipline available out of the delivery of transportation services, we should be eliminating all barriers to the market for transit services and instead subsidizing the mobility budgets of low-income households. Then let the market operate, let entrepreneurs enter the market to try and capture the demand that they know exists because low-income households have got a transit subsidy. And at that point, if we don't like what happens, if we don't like the result, if we don't think there's enough service, then maybe we think about using public authority to provide some additional service. But we should let the market operate first and just set the system up to operate in a way that allows it to deliver what we want, which is not what we do right now, unfortunately. So we're back to this universe and the punchline. Metro has a long history of overpromising and then failing to deliver on capital projects, ultimately making conditions worse for Los Angeles transit users. The 28 by 2028 plan exacerbates these existing problems. This is quite an important punchline. Metro has spent or allocated $26 billion in current year funds thus far on the LA rail plan. And that includes projects under construction, building far fewer total rail projects than promised at greater cost. And most important of all, this is really key, at greatly diminished transit use. The more rail we have built, the less transit ridership we see. There's no practical possibility that Metro would be able to fund or complete all of the 28 projects in their plan. If Metro implements the plan, that plan's emphasis on new rail lines will come at the expense of bus service. Billions more will be spent, and overall rail transit service and ridership will continue to deteriorate just more quickly. There is more. I'll show you some data in just a moment, but let me give you some summary figures. Metro is losing ridership quickly, and this is pre-COVID. Post-COVID, or during COVID, ridership went to zero, effectively, about 10% of what it was. But pre-COVID, Metro was losing ridership quickly, despite population growth. Ridership in unlinked passenger trips was down 20% from 2013. Unlinked passenger trips per capita was down 37%. That is, if we try to account for population growth. That's from the all-time peak in 1985. We've never returned to that peak. Our greatest transit use in Los Angeles was 36 years ago in 1985. And linked trips per capita, that is end-to-end trips. And an unlinked trip is a trip segment. They're easy to count. A linked trip that goes from location A to location B, possibly taking more than one vehicle, that's harder to count. But linked trips per capita are down 42% from that 1985 peak. And remember, we've spent $26 billion to accomplish this. If pursued, the 20 by 28 plan will collapse. It's just a matter of when, but I promised you some data. Let me try to get to that. Data, all right, since I want to speed up a little bit, and I'm not going to be able to deliver the full 25 minutes that I promised. I want to try to keep us a little bit more on schedule than that. But this breaks down ridership across modes. So where Metro gets into trouble is its decision to try to deploy a rail transit system. Now, there's nothing wrong with rail. Some places in the world, rail makes sense. The train between Kowloon and Hong Kong Island was built without subsidy. It paid for itself. That's the fact that it generates more revenue than the value of the resources it consumes makes it very clear that there are net benefits in the provision of that service. If you look globally, ridership on rail transit systems are predicted fairly accurately by two factors, really, population density and the price of gasoline relative to income. And in North America, urban densities are low relative to the rest of the world, and the price of gasoline per unit income is very low relative to the rest of the world. So frankly, in North America, rail transit is not a very good bet in terms of attracting ridership. And that's what we see in Los Angeles. This is sort of interesting. In 1982, we began receiving funds from Proposition A, the first sales tax measure that I mentioned, and we used those funds to suppress fares on the bus system to 50 cents per ride. So we've got bus down here, that's this blue figure. And between 1982 and 1985, we see the most successful transit experiment in the history of North America. Transit ridership in Los Angeles soars because typically the people on buses are very low income and they're very price sensitive. And reducing the cost of travel provided more options in their lives, and they traveled quite a bit more. In 1985, at this peak, which we've never again managed to revisit, we began shifting capital from Proposition A to an account to pay for the first light rail train added to the Los Angeles system. That train was added in 1991. So we see this green area where we see the appearance of a little bit of rail transit ridership. Prior to that, because bus fares had gone up and because resources were being diverted from operating the bus system to constructing rail, we saw a continuing decrease in rail transit ridership, bus transit ridership. That decrease continues. We do add some rail capacity, and that does add some ridership in some years, but overall we see a decrease in ridership down to around 1996, at which point the MTA is sued by the NAACP, which is a group that was formed in the previous century, basically to support the rights of African Americans. And this entity said, look, when you make hopelessly inefficient decisions, you make the transit service pie smaller for everyone, and that includes members of federally protected groups whom we represent. So over the course of 2 years, the MTA was sued in federal court for civil rights violations because it was making, frankly, such really economically poor transit decisions. And in 1997, they settled in federal court. The judge was Judge Hatter. When you settle a federal lawsuit, there's a consent decree in which the judge gives the outcome the force of law. And that consent decree said that for the next 10 years, Metro could build all the rail that it wanted, but it had to meet certain basic service requirements with respect to the bus system. This service requirement was a load factor. Basically, a limit was placed on how crowded a bus could be on average anywhere in the Metro system. And the only way to achieve that average turned out to be to add buses, to add bus lines, to add more buses per line, to expand the hours of service, basically to improve options available for bus riders. And we saw as a result, between 1997 and 2007, a steady increase in total transit ridership in Los Angeles. There was a special master appointed by the court. His name was Don Bliss. He had to review all of the operating plans of MTA year by year. And if they weren't conforming with the terms of the consent decree, he would inform the federal court. And he had to inform quite a bit, frankly, because the MTA tried its very level best to try to evade the terms of that agreement, but they were held to them. But then in 2007, the consent decree expired, and what we see is this steady reduction in total transit use in Los Angeles that comes about because it is at this point we see resources, shifted from bus operations toward efforts to keep construction of new rail lines on schedule. And unfortunately, that means less bus service. There are people on the buses. Those riders are no longer being served. I don't know exactly what is happening to them. Some people are showing up on the trains, but more people are leaving the buses than are showing up on the trains. And we're building the trains at considerable expense. So still checking the clock here. I'll give myself another couple minutes to make my point, and then I'll stop. So this is the same data in aggregate. Basically, we've got this period of rapid growth that comes from lowering the price on transit. Here we've got a continuing decline in rail transit and total transit ridership that comes from raising the price that people have to pay to use transit. Here we have reductions in price and improvements in level of service supervised by the federal court. Here we have what happens when the MTA stops conforming to these measures and goes back to business as usual, which is basically bleeding the bus system to construct more rail. And this line is the increase in Los Angeles County population. It's not drawn to the same scale as the other graph. Total increase here is probably in the neighborhood of about 20%. But what's important is 497 million boardings in 1985. We got close again in 2007, but not quite there. Note that 497 million boardings isn't 497 million different people. People who use the bus use it many times during the course of the year. There are 250 work days in a year per person, for example, and 2 trips per person. These are unlinked trips, so they also reflect the fact that I'm not going to show you that. This is an income distribution. The people who are on the Los Angeles transit system are, by and large, fairly low income. So what have we got? If we look at bus riders, about 70% have got incomes in the $15,000 to $25,000 a year range. 90% perhaps are in the $35,000 or in the, say, the below $50,000 a year, at or below $50,000 a year. I take the train back and forth to work. I only live about 3 miles from USC, so the train's a very simple option for me. And I notice sometimes not only am I the only person on the platform who is wearing a tie, I'm frequently, I think, the only person who owns a tie. Frankly, these are very low income households using transit who are being served by transit, and their interests are harmed if we don't manage the transit system effectively. Unfortunately, we are not. Last point here, reconfiguring bus lines to feed rail lines increases the number of transfers needed to complete a trip. One of the things that Metro has done to try to justify rail is to set up the system so that rather than taking 2 buses to get from A to B or 1 bus to get from A to B, most riders have to take a train, which means they take a bus to the train, and then they take the train, and then they take a bus away from the train. Nationally, there's about 1.4 unlinked passenger trips per transit trip in the United States, which means about half of those trips are 1 vehicle, half involve 2 vehicles. The average number of unlinked trips per trip on the metro system exceeds 3 for both bus and rail. So we've got nationally more transfers than anybody else in our system. And those transfers diminish reliability, they increase inconvenience, they increase delay and uncertainty, and they diminish the utility and attractiveness of transit for the people who would otherwise be using it. So I will skip all of this. There's a lot here, and I knew I wouldn't be able to get it all to you. Okay, sales tax revenues. This is worth a quick mention. This black line is actual sales tax revenues for Measure A, our oldest sales tax. And these colored lines are the various sales tax revenue forecasts that Metro has created. The lines with these figures in them, the dots, are forecasts that my colleague and I came up with. So let's see, this forecast here is our lowest, our most conservative forecast. It's just ordinary least squares of the observed trend in what revenue forecasts have been, what revenues have been observed from Measure A. Then we've got a fixed annual growth rate, the simplest sort of naive model you can imagine. And then we've got a growth rate that relates, I can't find, there we go, a log least squares growth rate. So these three forecasts are all just the sort of simplest naive statistical forecasts any of us might make. And they do better, frankly, in terms of accuracy than 100% of all of the forecasts that MTA has ever made. MTA primarily inflates its sales tax forecasts, I think, to inflate its bonding capability so that it can float really more public bonds than it can afford and ultimately will ever be able to repay based on these sales taxes. So just an inventory of, on average, MTA's forecasts are 300% above what is actually observed. Pretty dismal performance overall. This forecast was pretty good. This forecast was pretty bad. This is Measure M. So this is the most recent sales tax forecast, and this red line is what Metro predicts it's going to generate in terms of revenue. This black line is the pattern for Measure A revenues, and these colored lines down here, blue, green, and magenta, are just the three simple naive forecasting methods that we have applied to Measure M funding based on the pattern of growth we saw in Measure A. So again, just the simplest sort of modeling one could do if you wanted to do back of the envelope financial calculations to decide how much you can afford to spend, yet somehow MTA manages to be incredibly optimistic when it comes to deciding how much money it's going to have in its coffers to build trains that are ultimately going to reduce transit use. All right, so I think rather than drag you through all of these travesties of accounting, I think I have to rush to the end here. I'm not going to give you, I mean, the 28 by 2028 plan has many elements, and we looked at all of them, and they're all amazingly optimistic. They're headed, frankly, for a massive financial fall. They can't afford, even if we look, not even at the 8 additional projects that they want to build, if we just look at the 20 they're committed to, their revenue forecasts are so far wide of the mark, they're going to find themselves in the middle of building a number of very large projects for which they are simply going to run out of money. And what they will do is come back and ask for more money, and their position will be ignore sunk costs. Don't think like an industrial engineer. If we don't finish the system, you'll have wasted all of the money that we've already spent on it. None of that is true, of course. What matters is what benefits can be derived from the next dollar you spend, not from the money you've already spent. And if you've misspent money on rail in the past, that's really no reason to continue to do so in the future. You should step back and reevaluate the investments that you've made, and think about, take delivery on what the data shows us, and think about the mode investments that will actually amplify transit use and the value that is being earned for the public resources being expended. And that, I believe, is going to bring us to the end. We do talk about this publicly. We've written a number of op-ed pieces, and we keep writing them and we keep publishing them. And I'm a little depressed and discouraged because ultimately the impact of doing this has been really absolutely nothing. we've been unable to revise the practices of this agency, regardless of how much analysis we do. And I haven't figured out quite yet how I can amplify the impact of this work so that maybe, just maybe, we'll quit taking sales taxes from people who really can't afford to be so adversely affected by regressive taxes and deploying them in a way that reduces the services available to them. I'll stop there.
Okay, thank you, Professor Moore, for your sharing about the Los Angeles Metro's plan. Now we will continue to the second session, which is the Q&A session. And we already have so many questions in the chat box, and some of them has been answered by Dr. Indah. So maybe I just highlight some of them. The first question is from Mr. Ricardo. In this system dynamics, when we consider the constraint associated with condition, this question is for Dr. Indah. And the answer from Dr. Indah, yes, there are constraints in the model. Also, sensitivity analysis was done. Due to the limited time, I didn't explain all the complete process, but all the stages were done in the research. Thank you. Okay, and next, the second question is from Mr. Priyono from Universitas Kristen Maranatha or Maranatha Christian University. The question from Mr. Priyono is, in the current pandemic situation, what are the practical examples of selecting the most suitable system dynamics for determining decision-making in industrial engineering, and also what practical examples of the most frequently determined parameters? Thank you. And the answer from Dr. Indah is, the issue suitable now is about the industry sustainability. Examples of parameters in the model is adoption fraction from the word of mouth, marketing effectiveness, time for activating OLT to OD, and discount rate for customer equity. Thank you. And then the next question is also for okay, sorry, I just scrolled the question out and then. Okay, the next question is also from Mr. Ricardo. I think this question is for Dr. Tan. Can we apply pairwise comparison on mean variance decision-making process? Okay, for Dr. Tan.
Okay, yeah. So definitely we can do pairwise comparison. It's just that in this particular case, it's not really necessary because it's just based on the expected value of X and Y over there. So since it's only just based on the expected value, I know that if let's say X is a lot better than Y, and X is a lot better than Z, then I do not need to consider the relationship between Y and Z, because I know that X is essentially the best out of the three already. So for the numerator, we always kind of use the one with the largest expected value. But that is a great question, because this is only for this very simple case where we are assuming that losses are not possible. So if losses are going to be possible, that's where the decision becomes a lot more complicated. It's no longer just based on their expected estimated utility value, but it's also going to depend on the largest possible loss over there. And then that depends on the loss of each of the individual random variables. And so under that situation, then yes, pairwise comparison is going to be necessary. Yeah, so that's a fantastic question. In fact, I didn't go into the details of that. So yeah, once losses are possible, then we do need to go for pairwise comparison. David, hand it back over to you.
Okay, thank you, Dr. Tan, for your answer. And the next question is for Dr. Indah. This is from Mrs. Ingrid. May I know, based in your experience, what is the best or friendly SD software now? And the answer from Dr. Indah is she used fan sim and power sim. Okay, and the next question is for Dr. Tan. This is from Mrs. Angela. Dr. Tan, thank you for your sharing. Just a quick question about your research. Have you done related work on investors who are risk averse or risk takers?
Yeah. So, the work I've done, actually, you can apply them to both risk adverse and risk taking decision makers over there. So, because as mentioned, for risk adverse decision makers, very often we just describe them using concave utility functions. Of course, there are some level of approximation over there, but assuming that our decision maker is described by a concave utility function, then the results I've explained over there then works. In fact, that's where the mean variance rule actually applies. So if our decision maker is actually a risk taker, then the typical approach is that we would then model their utility function using a convex utility function. Then under the situation, the rules that I have will still apply. The mathematics is essentially more or less the same. The only difference over there is that then having a higher standard deviation is generally going to be preferred as well. Okay, so that's the only kind of difference over there. That's all. Yeah. So, but in terms of the mathematics, it can be applied to both the risk adverse and also risk taking decision makers. David, back over to you.
Okay, thank you, Dr. Tan. And the next question, I think this is for Professor Mu. The question is from Mr. Ricardo. Is the policy on metro transportation vary or different from state to state in the US?
It does, and not only state to state, but county to county. So there is federal transportation policy. The lion's share, the federal government passes a lot of centrally collected resources back to the states, and then the states make locally based decisions. And that makes sense. I mean, the states are closer to their objectives than the federal government is. But one of the things that's unique about the Los Angeles situation is they more or less invented these local sales taxes. And these sales taxes never terminate. They go on forever. So they don't sunset, they don't last for 30 years and then stop. These sales taxes will continue to generate revenues for this agency as long as the agency exists. And even if the agency disappears, the revenues will be collected and they'll go to some other agency. But that has made it possible for this agency to invest in a number of really significant projects. And some of them have been just great. But it's unfortunate that such a large share of what they have available to invest is frankly going to the wrong mode because it's diminishing transit use. It's happening for political reasons. But this maneuver of local sales taxes has gotten a lot of attention, both within California and at the federal level, and it's a strategy that has been emulated by some other counties within California and elsewhere. But yes, there's a lot of variance.
Okay, thank you for your answer, Professor Moore. And the next is, this is a comment from Professor Franz Mardi for Dr. Indah. He said that, Dr. Indah, I have used system dynamics in the early 1970s to study the impact of the Jatiluhur Dam to the region. Based on the experience, our greatest problem is created by the use of alternate logics in understanding the stop and flow algorithm, which is in system dynamics is considered to be linear. We begin to observe discrepancies when people use lateral or circular or paradox logics. Besides that, we have to understand that what we see is usually different in what we perceive. Okay, thank you, Professor Franz Mardi, for your comment to Dr. Indah. Okay, and the feedback from Dr. Indah to Professor Franz Mardi. Yes, system dynamics is circular with feedback loop, not linear. When facing the differences between what we see and perceive, we could support the model with the relevant variables in the literature. If still not accommodated from the literature, that my new contribution to the field of system dynamics in my case is in synchronization between acquisition and capacity planning and between acquisition and retention. Thank you for attending this seminar, Professor Frans Mardi. Okay. This is also the comment from Professor Frans Mardi for Dr. Tan. He said that, Dr. Tan, very enlightening. I would like to know how you accommodate the decision maker's background and past experience in your model.
Okay, yeah, thanks, David. I'll take this as well. So, yeah, so thanks for the question as well over here. So, yeah, there are definitely ways that we can take advantage of, let's say, the decision maker's background or his or her past experience over there. So, if you look at the literature, there are actually decision scientists, psychologists that have done experiments, or I would say surveys with different groups of people over there. Okay, and so they have spoken to CEOs. They have asked, they have tried to estimate the utility function of CEOs, of middle level managers, of operation managers, and so on. And so, for example, if your CEO is too busy, right, for you to ask a series of questions to estimate his or her utility function, then this is where you can revert to some of these earlier studies over there, and you can make use of those estimated utility functions. In fact, studies have shown that sort of like generally speaking, higher level managers tend to be less risk adverse compared to lower level or compared to, let's say, the ground staff over there. Okay, and but obviously it really depends also on the culture, the context, and also the industry. Okay, so there are definitely these studies that we can take advantage of. Alternatively, what you can also do is, let's say, if you kind of have access to the historical decisions that the decision maker has made. So for example, you're looking at a plant manager, you are able to look at what are all the decisions that the plant manager has made in the past. You can actually use those to kind of infer his or her utility function as well. So those are some of the things that you typically can do. But of course, the standard way is, if your decision maker has time to spare, you ask a series of questions to estimate his or her utility function. Okay, so I think that's probably what I have to give in response to that. David, I hand it back over to you.
Okay, thank you, Dr. Tan. And the next question is from Professor Frans Mardi. This is for Professor Moore. He said that, Professor Moore, thank you for your presentation. Have you do any surveys to understand the real needs and expectations of the people of Los Angeles for the metro system?
Fine question. Thank you for asking. All right, so I don't do much survey work myself, but there are a number of surveys that are useful and relevant. The Southern California Association of Governments will periodically survey households and transit users. That's our metropolitan planning organization that accounts for the 5. They're responsible for a lot of the transportation programming decisions in collaboration with Metro for the 5-county area: Los Angeles, Ventura, Riverside, San Bernardino, Orange. Then there is the National Personal Transportation Survey, which asks a number of commuting and household level and transportation behavioral related questions. And this is done federally perhaps every 7 years or so. It's not done on exactly the same schedule as the decennial census. The census has got relevant transit and transportation questions that we can use to analyze demand for transportation by a number of modes. And then the American Housing Survey has got some transportation related questions. We're getting more data from sources like INREX. I mean, there's been a data revolution in transportation the same way there's been a data revolution in everything else. I was trained during a period of data parsimony, and now we're up to our eyes in data about how people travel and what they want to accomplish and what they want to consume that might drive their travel. But pro vehicles and systems like INREX, I think, have been incredibly valuable in determining how people travel. When MTA will survey its ridership also, but MTA has a tendency to to survey populations whose responses are fairly predictable. They'll survey train riders and ask if we should invest in more trains. Well, people who are on the train find trains useful, so they will say yes. They'll survey bus riders and say, should we invest in more buses? And the bus riders will say yes. They'll survey people who don't take transit and say, transit will decongest the roads. Should we build more transit? Should we invest in more transit? And so the MTA's surveys tend to be a little bit manipulative, but we've got a number of other, I think, fairly objective and comprehensive data sources on which we rely. So that's the short answer is I don't do survey work. I do survey analysis work, but I spend most of my time analyzing other people's data. And
Okay.
I love listening to Dr. Tan. He's got a great way of speaking, right? I mean, I wish my platform presence was as good as his. It's very nice.
Thanks, Prof. Mo.
If I see Dr. Hartman, I'll tell him you did a great job.
Oh, you know Dr. Hartman. Thanks,
course.
Prof. Mo. Yeah, he's my PhD supervisor.
One of my best friends. He's a great guy.
Oh, nice. Send my regards to him. Thanks.
Certainly.
Okay, thank you, Professor Moore. Such a compliment for Dr. Tan, I think. Actually, I have another question for you, Professor Moore.
Yes, sir.
In your opinion, what is the biggest or the most significant role as industry engineer in terms of solving the problem faced in the metro system?
I would say the biggest, the most important tool that we bring to the table, frankly, is engineering economy, right? Because most of what I've had to talk to you about tonight has come from taking an engineering economic view of this transportation enterprise as if it was a business. So taking the agency's performance and comparing it to the benchmark of the kind of decision making that we would expect from a business really does force scrutiny that would not otherwise occur. And while I get frustrated about the quality of the decisions that do get made, and I'm unhappy that I'm not able to influence them to the extent that I would like, it is possible that decisions that do occur take place a little bit differently because this kind of analysis is taking place. So as an industrial engineer, what I like about this is these questions could be left to the civil engineers, right? Any engineering you do in a public context could logically be classified as civil engineering, but these are really industrial engineering questions. The quality of resource decisions being made to meet an objective where there are where there's a great deal of uncertainty and a lot of competing alternatives, right? Well, civil engineers are good at finite element analysis, and I'm glad that they are. But how to operate your transit system really is, how best to do it really is a set of industrial engineering questions.
Okay, thank you, Professor Moore, for your response. And I have another question. This is for Dr. Tan. In your opinion, what is the biggest challenges that we may face in making a decision under uncertainty condition? Maybe you can comes into the mathematical model or something else.
Okay, Ken. So thanks for the question. That's a wonderful question. I probably don't want to go into the mathematics of it. Perhaps the mathematics that I've described has bored everybody. But I think my response to that is when it comes to making a decision, the biggest challenge, I have to be honest, I don't think it's going to be the mathematics of it. Essentially, the mathematics is just for us to come up with a justification as to why we kind of make that decision over there. What I've observed in practice very often is going to be the difficulty comes in terms, I would say twofold. The first is to make the decision. As I mentioned, when you make decision under uncertainty, people are always very concerned. You know, they want to consider all the different scenarios, and then everything complicates things, and then they procrastinate, and in the end, they don't make a decision. I think the first difficulty comes in terms of biting the bullet and saying, okay, I just need to make a decision, and then I'll move on from there. I think the second difficulty over here is to then accept the decision that you make. When you are making decisions under uncertainty, it is impossible for you to always be making the correct decision. So, for example, I talk to people who are interested in investing in stocks and shares, right? Very often, the question that they ask me is, which stock is going to go up, tomorrow? Which stock is going to go down tomorrow? We never know, right? So I think the idea over here is having to embrace the decision that you make and realizing that you cannot always be making that right decision, realizing that making wrong decisions is part and parcel of the process. But if you are making your decisions in a systematic, rational way, in the long run, you're always going to be better off. So I think, to me, I think these are the two biggest challenges over there. Make that decision and don't be affected by the outcomes that you have made, so that going ahead you will still continue to make those decisions quickly. Yeah, David, that's what I have to share.
Okay, thank you, Dr. Tan, for your answer. I think this is the end of the session since time flies so fast. Thank you for Dr. Indah, Dr. Tan, and Professor Moore for your sharing today. I believe that we all got so many knowledge and so many enlightenment in the field of related industry engineering. So I give it back to Miss Christina. Thank you.
Yeah, thank you. Thank you so much, Mr. David, for moderating this seminar event. And also, we would like to thank again for Professor Moore and Professor Tan, and also Dr. Indah, and also Mr. David for doing this seminar. Will be very, very great. And this is the what is it like a very great moment for knowledge sharing for all of us, for the students, and also for the faculty members, and also for the employee. And I hope that this will be very, very fruitful for our life and could be implemented also for the knowledge here. Yeah, thank you so much. And we are now at the photo session right now. Maybe Professor Moore and Dr. Tan will not know about the Indonesian tradition about the photo session, but I don't know if you can adapt also later in the US and also in Singapore for the photo session. Because in Indonesia we also have like not habit, what is it like, culture. After we have the seminar, we also have the documentation with the photo session together, so it will be remembered later in the later years or something. Yeah, maybe all of the participants can open their camera and give the best smile for this documentation session. And we will also would like to greet Professor Franz Madi Hartanto here, the great professor from ITB, the Institute Technology of Bandung. Hello, Professor Franz. Thank you for participating in this seminar.
Thank
And
you, and hello to all of you.
yeah. Yeah, thank you so much. Okay, wait. Yeah, we'll have the photo session together right now. So I will just count to 1, 2, 3, and we have like 14 screens here. Uh, it will be a great number of the participants for the seminar. Okay, the committee for the documentation session has been ready. Okay, so give our best smile and hold the best smile until 14 screens finished. Okay, 1, 2, 3. This is the first screen, and we move to the second screen right now. Okay, still give the best smile. 1, 2, 3. Okay, we move to third screen. From all of the 14 screen, give your best smile still. Okay, 1, 2, 3. Okay, so we move to the fourth screen. Okay, still give your best smile. 1, 2, 3. Okay, so we move to the fifth screen. Okay, 1, 2, 3. Yeah. So we move to the sixth screen. 1, 2, 3. Okay, we move to the 7th screen. 1, 2, 3. Okay, we move to the 8th screen. 1, 2, 3. Okay, we move to the 9th screen. So I will change to Indonesian language right now. 1, 2, 3. Yeah. So we move to the 10th screen. 1, 2, 3. Okay, we move to the 11th screen because I think most of the participants here from Manila, Philippines, maybe. So I will change to Tagalog. What is it? Isa, Dalawa, Tatlo. Okay. So we move to the next screen. Is it 12th screen? I think. Yeah. Okay. I changed it to Chinese. E, San, if I'm not mistaken. Okay, I'll change to English again. So it's like a changing mode of the language right now. Okay, 1, 2, 3. Okay, is it 14 screen already? Yeah. Yeah. Wait. Wait. So, right now we will have the. Wait. Yeah. Yeah. So we will have the feedback survey session right now. So the committee can share the link right now over here. So I will give approximately maybe around 2 minutes to fill it in currently right now. And the e-certificate will be sent to your email registered in this feedback survey.
Don't have to say a word to you. You seem to know whatever mood I'm going through. Feels as though I've known you forever.
You can look into my eyes and see the way I feel and how the world is treating me. Maybe I have known you forever. Amigos para siempre means you'll always be my friend. Amigos per siempre means a love that cannot end. Friends for life, not just a summer or a spring. Amigos para siempre. I feel you near me even when we are apart. Just knowing you are in this world can warm my heart. Friends for life, not just a summer or a spring. Amigos para siempre.
We share memories I won't forget, and we'll share more, my friends. We haven't started yet. Something happens when we're together.
When I look at you, I wonder why there has to come a time when we must say goodbye. I'm alive when we are together. Amigos para siempre means you'll always be my friend. just a summer or a spring. Amigos para siempre. I feel you near me even when we are apart. Just knowing you are in this world can warm my heart. Friends for life, not just a summer or a spring. Amigos para siempre. At you, I wonder why there has to come a time when we must say goodbye. I'm alive when we are together. Amigos para siempre means you'll always be my friend. Amigos per siempre means a love that cannot end. Friends for life, not just a summer or a spring. Amigos para siempre. I feel you near me even when we are apart. Just knowing you are in this world can warm my heart. Friends for life, not just a summer or a spring. Amigos para siempre. Friends for life, not just a summer or a spring. Amigos para siempre.
Yeah. Okay. Thank you for filling the feedback survey. And finally, we come to the end of our seminar and would like to say thanks again for our honorable speakers, Dr. Indah, Dr. Sandroto, Dr. Tan, and also Professor Moore, and also Mr. David for being the moderator for this event. And also, thanks again for the all informative knowledge that has been shared. Hopefully the presentation will be very, very fruitful for everybody in the life. And thanks for attention, everybody, and keep safe and healthy. See you in our next event. Thank you. Bye bye. Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you very much. Take care.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Thank you so much.
Bye bye.
Bye.
Atur nuhun, Kang.
You can look into my eyes and see the way I feel and how the world is treating me. Maybe I have known you forever. Amigos para siempre means you'll always be my friend. Amigos per siempre means a love that cannot end. Friends for life, not just a summer or a spring. just a summer or a spring, amigos para siempre.
We share memories I won't forget, and we'll share more, my friends. We haven't started yet. Something happens when we're together.
When I look at you, I wonder why there has to come a time when we must say goodbye. I'm alive when we are together. Amigos para siempre means you'll always be my friend. Amigos para siempre means a love that cannot end. Friends for life, not just a summer or a spring. Amigos para siempre.